Okay, so here's 4.1. 4.1 has a lot of different terminology, kind of brings back some old ideas from geometry. So it's kind of a little bit jam-packed, but mostly with some basic stuff. So we're essentially going to be talking about radian and degree measure. So talking about the unit circle has already gotten you reacclimated with this a lot already, so I think that'll be a little bit helpful for you. First thing I want to remind you is when we're talking about an angle measure, it has a vertex where those two rays meet, the initial side is where that angle starts, and then the direction we're going in goes to the terminal side. Super easy, initial start, terminal end. So when we're calculating angles, an angle that is positive would be going in counterclockwise direction. An angle that is negative would be going in wait, did I say counterclockwise for the first one? I hope so. Counterclockwise for positive, clockwise for negative, okay? Again, pretty basic stuff. So we're going to use those ideas to find coterminal angles. So I forgot to put the definition at the top, but I put it down here at the bottom, so I'll kind of jump down to that. Two angles are coterminal when they have the same initial and terminal side. So an angle that has the same starting and ending point will be coterminal. Okay, so obviously they have to be two different kinds of angles, or two different measures of angles, but they should start and end in the same place. So if I want to find the coterminal angle for 13 pi over 6, what I'm going to do is take 13 pi over 6 and subtract 2 pi from it. So what I'm doing here is finding a common denominator of over 6. 13 pi over 6 minus 12 pi over 6 is the same thing as 2 pi. If you subtract those, you get pi over 6. So we should know from doing our unit circle where pi over 6 lies on our unit circle. Pi over 6 would be that first line that's only 30 degrees in. So if we look at 13 pi over 6, that would go all the way around and back up to pi over 6. How do we know that? An entire unit circle is 2 pi. If you break down 13 pi over 6, it's essentially 2 pi in 1/6 pi. So that's saying that it goes all the way around and back up, just pi over 6. So pi over 6 starts in the same place and ends in the same place. Okay, so they are two coterminal angles. Another example. When we're looking at the next one, I want to find a coterminal angle, of 3 pi over 4. So again, what I'm going to do is take 3 pi over 4 and subtract 2 pi from it. Okay, if we take 3 pi over 4 and subtract 2 pi, we are going to be getting negative 5 pi over 4. Okay, this number is smaller than this number, so I should get a negative number. So let's think about how we would draw this. So 3 pi over 4 is over a half, so it's over in this quadrant. It's the middle term in this quadrant over here. So here's 3 pi over 4. Here's my first angle. So I need an angle that starts in this place and ends in here. So a negative angle is going to go it's going to go clockwise. It's going to start here. So negative 5 pi over 4 would go all the way over that direction. Okay. What I want you to remember is that there's multiple or really endless coterminal angles. This is one of them. There's also a positive version that goes all the way around and back here, right? So it'd be 2 pi plus 3 pi over 4. So you can either add on 2 pi or subtract 2 pi in order to find a coterminal angle. Next quick thing we're going to go over is degree conversions. So at certain points in time, it's going to be really helpful for us to be able to convert back and forth. And I cut some of it off. To be able to convert back and forth between radians and degrees. So this is going to be interchangeable from one to the other. If you go from degree to radians, oh, sorry, that's why that was just a one-sided arrow. My bad. If you're going from degree to radians, you will multiply by pi over 180. And if you're going from radian to degree, you multiply by 180 over pi. So the thing you're going to goes on top. Or if we're going to go to radians, pi goes on top. If we're going to go to degrees, 180 degrees goes on top. So I want to convert 135 to radians. So if I'm going to radians, pi goes on top. So I take 135 and I multiply by pi over 180. Okay? So when you multiply a whole number, sorry, I got an itch. When you multiply a whole number by a fraction, whole number goes on the numerator. So we get 135 pi over 180. If we simplify that fraction down, we get 3 pi over 4. 540 to radians. Again, 540 times pi over 180. That's 540 pi over 180. We can simplify this down to 3 pi, just taking 540 divided by 80. The last one, 9 pi over 2 degrees. So this is going to be 2 degrees, so 180 goes on top. 9 pi over 2 times 180 over pi. Again, when we multiply fractions, we multiply straight across. So 9 pi times 180. So specifically what we're going to do here is take the 9 times 180. So giving us 1,620 pi. And then 2 pi goes underneath because 2 times pi. Pi's cancel. 1,620 divided by 2 is going to give us 810 degrees as our new degree conversion. All right, final, last thing. Complement, I know I'm kind of going through these quickly, but it truly is things you've all done before in other classes, and you have the ability to rewatch this if you need to. So complementary and supplementary angles. So the way to remember this, complementary adds up to 90, supplementary adds up to 180, and specifically these should be two different angles adding up to 90 and two angles adding up to 180. So supplementary is because, so the way that I try to help people remember this and the way that some students have told me is supplementary is like a little extra. So it's going above and beyond. So supplement means it's bigger. So 180. That's just the way that people have kind of said that it helps them. Also, CS. S comes after the alphabet, after C in the alphabet, so it should be bigger. I don't know. People have tried to say that some of that stuff before that it helps them remember it. So what I want to do is find the complementary and supplementary angle of each of the following. So let's look at 72 first. If it has to be an angle that adds up to 90 for complementary, that's just going to be 90 minus 72, which is going to give us 18 degrees. Supplementary, same thing, two things that add up to 180, so 180 minus 72. So that's going to be 108. Okay, that's it for that one. Let's go over to 148. Complementary, is there any way that I can have two angles that add up to 148? We're looking at specifically positive angles, so the answer is no. Since 148 is larger than 90, there is none. Supplementary, 180 minus 148, that is going to give us 32 degrees. Okay? Degrees are fairly easy when we're talking about complementary and supplementary. Moving on to some radian measures. So I want to remind you, 90 degrees in radians is pi over 2. And 180 degrees in radians is simply pi. So there we go. Okay, so when we're doing this, we're going to take pi over 2 minus 2 pi over 5. Okay. Oh, can't really see that. All right. So of course we have to find a common denominator. Between 2 and 5, the lowest common denominator will be 10. So let's look at the first fraction. What do we have to multiply 2 by to get to 10? That is 5. So we have to multiply both the top and the bottom by 5. So 5 times pi is 5 pi. This is again just finding a common denominator. 5 times 2 is 10. Minus, what do we have to multiply 5 by to get to 10? That is 2. So multiply the top and bottom by 2. 2 pi times 2 is 4 pi. 5 times 2 is 10. Subtract 5 pi minus 4 pi is pi over 10. All right, supplementary, same thing. Pi minus 2 pi over 5. So the way that we can write this one is we only have to find a common denominator for pi. So this is going to be 5 pi over 5, because if you simplified that back down, 5's would cancel and you'd have pi. Minus 2 pi over 5 equals 3 pi over 5, because 5 minus 2 is 3. Last one, 4 pi over 5 for a complementary. You should already start to see 4 pi over 5 is larger than pi over 2, okay? Because 4/5 is larger than 1/2. So none, because 4 pi over 5 is greater than 90, or greater than pi over 2. All right, supplementary, pi minus 4 pi over 5. This can be 5 pi over 5 minus 4 pi over 5, giving me pi over 5 as a final answer. All right, that is it for 4.1. There was a lot in this section, but it's all super just kind of basic things that we just have to get the terminology down for. Okay, thank you.